Hi friends, this is Reshma. Welcomes you to discuss about the concepts of database management system. And in today's session, I'm going to discuss with you using relational algebra expressions to write the queries or that is to solve the queries. So now, before using the concept to write the queries, so here the first step to solve any query is identification of the relations which are required to extract the data. So means sometimes whatever the data required by us, it may be available in a single table, then extraction will be very simple. Sometimes the data will be available in multiple tables. In such cases, we need to extract the data from the multiple tables. Then writing the queries for single table or multiple table will be in different ways. Now to write the relational algebra queries, we have to make use of the relations or we have to make use of the operations which we have discussed in our previous session, and we have learned unary, binary and the basic or the derived operations in the relational algebra. Using those, today we'll try to solve some problems. So let's start with the very simple query, that is to find name and address of all the employees who works for research department. And as I said, the first step to solve any query is the identification of the relations, that is identification of the tables where our data is available. So that can be decided by seeing the question. So in the question, we need to retrieve name and address of employee. So where name and address will be available, as we already know the company database. So in company database, name and address of employee is available in employee table, and whose data, what type of that is here, which for which employee we need to extract name and address. We need to extract name and address of those employees who works for research department. If we see again company database, name of the department is available in department table. So that is now here we have identified that we need employee table and department table. So this is our first step. After finding the tables required, if we need more than one table, so then we need to extract data from these two tables. For that we need to go for join operation. So that is we need to join these two tables. Again, while joining these two tables, we need to decide which type of join is required, whether we need to go for inner join or outer join, whether we need to go for natural join or need to go for equi-join, theta join, that we need to decide. So now here in the solution, I need only the employees which are satisfying the condition, who are belonging to only research department. So here this shows that the result should be only from the matching tables. So we need to go for inner join. Again in inner join, whether I need to go for natural join or some equi-join. So by using the concept of the different join, if I want to go for natural join, I should have identical column names with the spelling name should be similar. Otherwise, I need to rename. So if I compare these two tables, I don't have any column which is having identical name. So now instead of converting the or renaming the attribute then applying natural join, so we can directly go for the inner join. So now here in inner join, that I will go for the equi join. So for equi join, I need to identify the joining attribute, and to retrieve the data I need to decide the selection condition. So here joining attribute which we can use is like the D number, because this is related to the department details, research department. So I will join D number from department table with D num of employee table. So now with the help of this attribute, we can join these two tables. So this is D number is now joining attribute. After joining these two tables, we need to extract only that tuple which will satisfy the selection condition. What is the selection condition here? Selection condition is D name equal to research. The employees who are belonging to research department only that should be selected. So D name equal to research becomes the selection condition. So now if we apply this join operation and selection condition, we'll get only those employees so who will belong to research department. And after joining, so what will be the result of join? That already we have discussed in our previous videos. So now for this particular example, so to write the query, by seeing the question what I want, I need only name and address. So we'll use project operation, and that is pi. So here we will find f name, l name and address. So whose f name, l name and address? So where joining condition is d num equal to d number, and then selection condition is d number equal to research. So this is the joining attribute. With the help of this joining attribute, department and employee tables will be joined. From the result, name, department name, research, only those tuples will be selected. So now here if I compare joining attribute, then we'll be getting, with the joining attribute we'll getting total 1 2 3 4 5 6 7 8, total 9 tuples which contains columns from both these tables. And then with the research department, so only research department belongs to department number 5, so it will extract the details of only department number 5. So 1 2 3 4 tuples will be selected. From those 4 tuples, only 3 columns we are displaying here. So that is for department number 5. See, research belongs to department 5. So for department 5, name is, first name is John, last name is Smith, address is 731 Fondon, Houston. So first tuple with 3 columns is displayed. Again now department number 5, we know it belongs to research department. So in second tuple, so here I will get Franklin Wang 638 was is the address. Then again 4 is not matching 4. Again this 4 is not a research department. So again here I have one more tuple with department research with department number 5. So Ramesh K Narayan will be displayed. Then again next tuple with the Joyce A English belongs to department 5, that is the research department. His name and address will be displayed. So like this we have joined 2 tables and extracted the data related to from these 2 tables. So this is the simple query which we have written. So now we'll go for the next query. So it is a little bit complex, not complex. So now here what I will do, instead of inline expression, let's write intermediate, taking the help of intermediate resultant tables. So now here in this query, so first we need to, first step before deciding the tables, first step is understand the question problem statement clearly. If you understand the problem statement clearly, half of the solution will be in your hand. So now here we need to find for every project located in Stafford, for every project located in Stafford. So we need to find the project number and the controlling department, the department who is controlling the projects located in Stafford, then manager of that particular department. So what details of the manager we need? We need name, address and birth date of the manager. So what is the question here? We need to find the name, address and birth date of that manager who is controlling the projects or who is working on the projects, so located in the city Stafford. So now we need to decide which are the tables required from the company database. So now to know the location of the projects, I need project table. To get project controlling department number, I need department table. So then to get his details, name, address and budget, I need employee table. So here I need to join 3 tables. Which are those 3 tables here? Project, then department and employee. So these 3 tables are required. So now we need to decide. So here single join and single selection condition is not sufficient. So instead of writing a single inline expressions, I will extract the data, required data from each relation, and that data I will use to get the solution in the next step. So what I will do here, first we'll, according to question, first we'll list the project numbers who are located in Stafford. So here I will take project. So now from project I need to select the project number which are located in Stafford. So that is our first step. So for simple query, single table I am using, no need to join. So directly select the project numbers or selecting the projects details where P location is Stafford. Then which tuples will be selected here? Tuple number 2 and okay, fourth. The project not 2. Okay, tuple number 4 and 6. The project name computerize is located in Stafford, and new benefits project is also located in Stafford. So this is the selection condition. No need of join. Directly I have extracted the data. So let's store that result in the new table with the name Stafford projects. So now Stafford project contain these two tuples, computerized and benefits project, which are located in Stafford. So now after finding this, what will be our next step? So now we need to apply join. So now we need to decide the departments which are controlling the projects. So Stafford projects are project number 1 and 4. Which are the departments which are working on these two projects? So here I need to join this result Stafford projects table with the department table. So now I need to join. Again here we need to decide the joining attribute. So what is the joining attribute here? So now your joining attribute is D number. I can join these two tables with the help of D number. So then we can get the projects which are controlling the departments which are controlling these two projects. Now here project number 1. If I see this table directly, I can say department 1 is controlling this project. What is the name of the department? Headquarters. The department headquarters is controlling the project, the computerization project, and here 4 belongs to administration working on new benefits project. So join these two with the help of joining attribute D number. So how to write this query? Table Staffords, join operator, department table, come here joining operator is D number. So now which tuples will be displayed here? It will match 5 is equalize here just. Is 5 equal to 1? No. 5 equal to 4? No. So these two tuples are not displayed. 1 equal to 1? Yes. So it will display computerized 10 Stafford 1 headquarters 1 triple 8 6 triple 5. Then again match 1 with 4, not matching. Then take this 4 matching with 1 S, the tuple will be displayed not matching. 4 matching with 4 is. Then new benefits with 30 Stafford 4 admin 4 997 will be displayed, and that result will be stored in controls department. Okay, so here 1 is equal to 1, that will be displayed. 4 equal to 4, that will be displayed here. So now from this table we have determined the data departments which are working on the projects located in Stafford. So still we have not got the complete solution. Now I need to determine the name of the manager. Now we need to know the employee or the manager who is managing these departments. Then how to find the manager details who is managing this department. So here I have manager SSN. Now I need to find who is this manager who is managing this department. So what I need to do now? Now I need to join this table with the employee table where I can get the details about this manager. So here now we need to join these controlling departments. So this is just repeated. Okay, the controlling departments I need to join with. So previous slide has repeated. Okay, so then I need to join these two tables. The first table contains details about the department which is controlling the projects located in Stafford. Now here these are the two managers. I need to get these two, get the details of these managers. So now go to the employee table and find who are these two managers. So now to join these, I can decide which is the joining attribute. stay because here we are finding the manager details and MJR SSN is anyhow here foreign key. Join that with SSN. So come join SSN of the resultant table with MJR SSN of resultant table with SSN of employee table. So just compare here. Is triple eight equal to 1, 2, 3? No. Is this matching with this? No. 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 Okay. Last tuple. Last tuple is matching with MJR SSN 888. So now in the resultant table we will get James E. Borg 888 1937, so etc. Then the first tuple. So last tuple of employee and first tuple of result. The previous this table will be displayed in the resultant table. Then match 987. Who is the employee whose MJR SSN is 987? So it will keep on matching with all these. Okay, now I got fourth tuple in the employee, so is matching with 987. So who is the manager here? Who manager here is Jennifer. So Jennifer is handling department 4, working managing department 4, and 888, that is James, is managing department 1. So now those two tuples will be displayed. So that is here, just see controlling department management employee by with this joining attributes. So now resultant table contains the complete. So now, do we need all these columns? Do we need so many details about the manager who is handling the departments 1 and 4, because they are working on Stafford's project. So no need of all these details. I need only name and address and birth date. So which columns will do name, address, birth date? So here F name, if you want you can take initial, L name, so this birth date and address. From this we can extract only the required tuple. How to extract only required tuple? Use the projection operation and select the required tuple. So now from this we'll select only required tuples. What are the required tuples here? So I'll take V number, that is project number 10. Which department is handling project number 10? Department number 1. Who is the employee? James. His address and birth date. Similarly, project number 30. Who is handling? So this is handled by department number 4. Manager of the department is Jennifer. It will be displayed. So we'll get the result. So these are the two managers who are working on the projects located in Stafford. So this is the solution for the required query. So now if you have any doubts in the query, please share your questions through the comment box. In my next session, I'm going to discuss with you some more examples and we'll see how to write the all relational algebra expressions for those statements. Thank you.